In this lesson, we're going to talk about how to write the prime factorization of a composite number. And we're going to use this skill later on to simplify fractions. It's very important to be able to break a number down into its factored parts. So first let's talk about what prime and composite mean. Prime means that no factors will go into that number. Nothing else goes into it except itself and 1, actually. A composite number is one that can be broken into factors. In other words, something will go into it besides itself and besides 1. Any number that's not prime is composite. For example, 2 is prime and 3 is prime because nothing will go into 3 except for itself and 1. Nothing will go into 2 except for itself and 1. However, 4 is composite because not only can 4 be divided by 4 and 1, but 4 can also be divided by 2. So since 2 goes into 4, 4 is considered composite. 5 is prime because nothing goes into it except itself and 1. 6 is composite because not only will 6 go into itself, but 2 will also go into 6 and 3 will go into 6. So let's practice writing the prime factorization for a few numbers here. Here's 70. The first thing to do is just break it down any way that you can. When I think of 70, the first thing that comes to mind is 7 times 10. Now this is not the prime factorization because 10 is not prime. So I want to break the 10 down. Oh, and by the way, the dot means multiplication, in case you are not familiar with the dot. In algebra, when we use an x for multiplication, it gets confusing because we frequently use an x as a letter x to stand for an unknown number. So instead of using the x, we use a dot to clear things up. Now, 10 is 5 times 2. So 7 is prime, 5 is prime, 2 is prime. This is the prime factoring for 70. All of those are prime. Now let's look at 24. Now I bet you can think of 2 or 3 different ways to break down 24. The first way I thought of was 8 times 3. Now 8 is 4 times 2. So 24 is 8 times 3, but if I break down the 8, it's 4 times 2 times 3. And then 4 is not prime, so I need to think of 4 as 2 times 2. So 4 is 2 times 2, and then this 2 is here, and that 3 is here. So the prime factoring for 24 is 2 times 2 times 2 times 3. Okay, let's try 100. 100, the first thing that comes to mind is 10 times 10. 10 then is 2 times 5. Each of my 10s will become a 2 times 5. If each of these is prime now, then this is the prime factoring for 100. And by the way, you can't do this wrong. If we had started by saying 25 times 4 or 50 times 2, then in breaking down the 25s and 50s, we would have still gotten to the same prime factoring numbers at the end. Alright, so 63, let's try to break down 63. I think of 9 times 7. 9 is composite, so 9 becomes 3 times 3, and I've still got my 7. So 63 is 3 times 3 times 7. And if we talk about the prime factoring for 11, well, 11 is prime, nothing will go into it. Let's do 20. 20 I could think of 4 times 5. 4 is not prime, so I need to think of it as 2 times 2. So the prime factoring of 20 is 2 times 2 times 5. Now, sometimes it helps to know the divisibility rules for the different numbers. We're only going to learn the rules for, say, 2 through 9, and not even all of those. But sometimes, you just need to be able to look at a number and know if something else will go into it or not. And that's what this is going to help with. So, you can tell if a number is divisible by 2 if you just look at it. All even numbers are divisible by 2, and that's the rule for 2. For example, 352 can be divided by 2 because it's even. 641 is not divisible by 2. 2 will not go into this number because it's not even. Now the rule for 3 is pretty interesting. If you didn't already know this, I think you're going to like it. The rule for 3 is add all the digits together. If the sum is divisible by 3, then the whole number is divisible by 3. For example, 573 is divisible by 3. I know that in advance because 5 plus 7 is 12 and 12 plus 3 is 15. Since 15 can be divided by 3, this big number can be divided by 3. Isn't that neat? I really like that trick. But 1252 is not divisible by 3 because 1 plus 2 is 3, 3 plus 5 is 8, and 8 plus 2 is 10. 3 won't go into 10, therefore 3 won't go into this large number. So see, it saves us a lot of dividing and a lot of working out things by trial and error. Alright, the rule for 4 is if the last 2 digits are divisible by 4, then the entire number is divisible by 4. This is only helpful if you have a 3-digit number, but it is helpful sometimes. For example, 532 is divisible by 4. I know that because 4 will go into 32. But 450 is not divisible by 4 because 4 will not go into 50 evenly. So this number is not divisible by 4. Alright, the rule for 5 you probably already know. All numbers ending in 5 or 0 are divisible by 5. 635 is divisible by 5. 342 is not divisible by 5. The rule for 6. If a number is divisible by 2 and 3, it's divisible by 6. Now this makes sense because 2 times 3 is 6. So if 6 is going to go into the number, then both of these things have to be able to go into the number. So, for example, 7,254 is divisible by 6 because, number 1, it meets the rule for divisibility by 2. It's even, so 2 will go into it. 7 plus 2 is 9. 9 plus 5 is 4. Let's see, 9 plus 5 is 14. 14 plus 4 is 18. 3 will go into 18, therefore 3 will go into this large number. So since 2 and 3 will both go in, that means 6 will go in. However, these two numbers are not. 435 is not divisible by 2. 655 is not divisible by 2 either. So neither one of these numbers can be divided by 6. Alright, now there are rules for 7 and 8, but they are so much trouble as to be not worth it. You may as well just divide. The rule for 9, though, is really cool because it's just like the rule for 3. Now, you know, 9 is 3 times 3, so it shouldn't surprise us that the rules for 3 and 9 are so similar. But again, we're going to add all the digits together. If the sum is divisible by 9, then the whole number is divisible by 9. So, for example, 6,273, because 6 plus 2 is 8, 8 plus 7 is 15, 15 plus 3 is 8, or 18 rather. So, since 9 will go into 18, 9 will go into this big number. And if we look at the other one, 4 plus 3 is 7, 7 plus 6 is 13, 13 plus 1 is 14. 9 will not go into 14, therefore 9 will not go into this big number. Okay, now, using all of those divisibility rules, we're going to be able to break down larger numbers than we ever thought we could, and that's what we'll do in the next example. So let's write the prime factorization for the following numbers. Here is 441. Okay, so what I would do if I were you is I would start looking for the largest number I can think of that will go into this. So since I know my divisibility rule's up to 9, I want to say, okay, will 9 go into this? Well, let's see. 4 plus 4 is 8, and 8 plus 1 is 9. Yeah, 9 will go into this number because 9 will go into itself. So 9 times what equals 441? Well, that I don't know off the top of my head, so I just have to divide and figure it out. And I find out that 441 is 9 times 49. Now 49 is not prime. 49 is 7 times 7. And also 9 is not prime. 9 is 3 times 3. So our prime factorization is 3 times 3 times 7 times 7. See, my two 3's come from here. 9 is 3 times 3. All right, let's do part B together. 1 plus 5 is 6, so 9 is not going to go into this number. But, you know, since 1 plus 5 is 6, 3 will go into this number. But look, also 5 would go into this number because it ends in 5. So I'm going to divide 5 into this number. You could use 3 as well. You get to the same place eventually. So 5 into 105 will give me 21. So I can think of this 105 equals 5 times 21. Now 21 is 3 times 7. So my prime factorization is 3 times 7 times 5. There it is. And let's look at 504. Because I look at the last two digits and I see that 4 will go into these two digits, then I'm going to divide this by 4. But look, 5 plus 4 is 9, so I could have also divided it by 9. But let's go ahead with 4. 4 will go into 504 126 times. Now 126, I can break down, and I don't have room to do the division here, but I look at 126 and I say, gosh, that's even. And also 1 plus 2 is 3, and 3 plus 6 is 9. So 2 will go into it and 3 will go into it, so that means 6 will go into it. So I broke down 126 as 6 times 21. And then 6 is 2 times 3. 4 is 2 times 2. 6 is 3 times 2. And 21 is 3 times 7. So when I write those in my answer, just out of, just trying to keep things straight, I gather up all the 2's and put them together. And I just happen to put these in order. It's not necessary. You see up here I did not put them in order, but here I did. 4 times 6 times 21 gave me 2 times 2 times 2 times 3 times 3 times 7. Now for 195, I notice that it ends in 5, so I'm going to try to divide it by 5. And I see that 195 is 5 times 39. 39 happens to be 3 times 13. And 13 is prime, and so is 3, and so is 5. So that's our answer there.